When we're studying pH, we're going to see that it's all about the concentration of the hydronium ion. The problem is those numbers tend to be things like 2.54 times 10 to the negative 6 molar, or moles per liter. What really matters with this number is not the 2.54. What really matters is the power of 10. This is 10 to the negative 6, which would be 1 in a million. So we're looking at an extremely small amount. Now the problem is we cannot imagine anything that small. So we want to put these values onto a scale that we can imagine. We tend to like numbers that are between, say, 0 and 100. If I tell you that you have 27 pencils, you can picture that very nicely. Or if I gave you something that wasn't an integer, like saying you had traveled 17.2 centimeters, you would be able to picture that very well. But numbers that are larger than 100 are hard to visualize, and negative values are hard to visualize as well. So because the concentrations of hydronium that we'll be looking at are so small, we need to invent a scale that makes these measurements fall between 0 and 100. In fact, when we look at the pH scale, it does two things. It focuses on the power of 10, and it makes it positive. So for the above example, the power of 10 is negative 6. This will end up falling on the pH scale somewhere around 6. So we'll see how all this works in the upcoming videos.